So hello everyone, Scott Benner from PJM. So PJM represents the 13-state region from Illinois to New Jersey, from Pennsylvania down to the Outer Banks of North Carolina. We've been using PLEXOS at PJM since about the 2015 timeframe, though in the last 5 years or so, we've been using it for a variety of energy modeling efforts. So just as a quick brief on various environmental studies we've performed with the PLEXOS tool. We've used it in some credit analysis after the Green Hat issue, and most recently we've been working on renewable integration studies. Though what I'm going to be talking about today is a piece of PLEXOS work that involved a forward energy and ancillary service task that we needed to complete. So dialing back to 2019, we were proposing a new reserve price formation change to our ancillary service markets. We would be introducing complementary day-ahead products to our existing real-time synchronized reserve and primary reserve, and we were proposing to introduce a new operation reserve demand curve, so a new sloped additional requirement to all of our products. And so in that docket, we argued that we were making so many fundamental changes to the reserve markets, we should come up with a new methodology for calculating how we're doing the net energy and ancillary reserve in our capacity market. So a component of our slope demand curve in RPM is a function, the price points are a function of the net cone and the cost of new entry, and that net is netted against the expected energy and ancillary service revenues. And so we had contracted out with a variety of parties to come up with a new projected EAS methodology that was going to look at not only different types of resources, but also using the forward market expectation to come up with whatever this new revenue was going to be. Now, historically, we had a SAS application that I would hesitate to call optimal. There was a lot of heuristics in there that was trying to estimate a CT and coal resource, but we had new technology on the rise, batteries, and things like that we needed new methodology to estimate. So one big difference in this modeling approach is when we think of things like our renewable integration study, I would call these price forming models, right? We go out, we get a bunch of fuel prices, heat rates, we, thousands of units, throw them in the mix, add a complicated network topology, and out fall market prices, right? Price is a output of that, of all those inputs. But in this case, our energy and ancillary service approach is what I would term price taking. So we're starting with what if the forward energy markets or the forward energy expectations and forward fuel expectations from S&P Global are correct. These are the kind of revenue that a new resource can expect to earn. These are kind of costs that the resource might see in their operations. So if you're dealing with price as an input, you don't need a network, you can solve one need at a time. It becomes a much simpler process. And so, boop. So in this particular task, we had new resource types that we needed to analyze. Historically, we had a 3-year look back. Well, we wanted to have a 3-year price shape for our forward ancillary service. So we would scale those all to the forward year of 2022 with respect to way back in 2020. And these were informed by not only forward market prices, but also our long-term auction of our of FTRs, which outputs congestion expectations. So we were able to take those zonal factors and bake that into what was projected to be zonal congestion. And so in this process, we wanted to look at that effect of a day-ahead market and a real-time market and the balancing settlement implications that fall out of that. So we reached out to Energy Exemplar to help us with setting up a model specifically to use the interleave function within their tool. And so If you need help within the PLEXOS help, I encourage you to search for the term automation on how to set up some of these interfaces that we had developed here. So looking at the process, we start out with an Oracle database. We're pretty retentive about keeping history and auditing and all that sort of stuff, so our go-to is Oracle. We use a tool to create Excel files, which we pump into PLEXOS through the import wizard. We farm them out to our on-premise cluster. PLEXOS does the work, it comes back with solutions, and then we use the operator interface to pull those solutions out of the repository, crunch all the numbers on balancing settlement, and pump it back into the database for retention. And then once we've completed all of our work, that's the information that got pumped out to our external web when we published our Net Energy and Ancillary Service report. And so this was running within a tool that PJM had developed, which basically automated all these functions into a interface that our operators, capacity market operators, could use, given that they are not necessarily PLEXOS experts, but they do have a handle on what these operating parameters should be. So within PLEXOS, we're starting out with these templates. I don't know how many of you have used the import wizard, but you're structured very similarly to PLEXOS itself, building objects, memberships, properties. And after importing that, we have a working PLEXOS model, which we can then farm out to the cluster. Now, when we run them, like I said, we wanted 3 different target years, so we're generating 8760 hours with those 3 base model LMP profiles. And then we use the solution API to pull the solutions back down, the query function to retrieve the values out of said solutions and do stuff with it. So just as a sense of setup, I'm going to run through our Atlantic Electric, New Jersey reference CT. So within this model, we had emission costs related to the operations of the resource. Depending upon, I listed coal accidentally, but in this case, the CT is running on either oil or natural gas. So we have multiple fuels that the resource can pick from based on the input prices in the given hour. We're also needed to have those participation memberships with the reserves. Now, in setting up a interleaved model, I'm not sure how many of you have done this, you basically build 2 models within PLEXOS. You make one the parent of the other. You execute essentially the day-ahead model, and PLEXOS will kick off the second simulation in parallel. And those 2 simulation models don't have to have the same horizon settings, though they do have to have the total number of hours equivalent. So they're both 8760 hours, just different configurations. So the day-ahead model's running 48 blocks of time, keeping the first 24 hours, advancing the clock. Real time was more of simulating what IT Sched would do with a sort of a 1-hour lock representing real time with a little bit of look ahead for commitment purposes. And as mentioned, these were all fed pricing. So we were using the scenario, the day-ahead and real-time scenario, to drive which file each interleaved model was going to see. Interleave will run those 2 models and produce 2 separate solution files within one run. So if you go and do a download to report, you'll see a day-ahead model and a real-time. But within those 2 models, they will have exactly the same properties. So in this case, we're interested in the output of the resource given the prices. So effectively, the prices create a short-run marginal cost. The real dispatch decision is should the resource be running given if it was inframarginal, and receiving those prices. And so we'll have all these day-ahead and real-time commitments for reserves. We also modeled a regulation reserve as well in real time. That product does not have a day-ahead equivalent. And then on the cost side, we need to know, how often is it starting up? Is it running uneconomically? And so this allowed us to calculate an uplift component to the day-ahead and real-time dispatch. And so that combined becomes our net energy revenue. So what's important in this is that we had a constraint, right? So a resource can get committed in the day-ahead market, but if it wasn't committed, well, let's put it this way. If it was committed in the day-ahead market, we want it to run in those same hours. But if it wasn't committed in the day-ahead market, we want it to be freely committable in the real time because the real-time price could be high enough to bring that CT on with a short startup time. And so the PLEXOS documentation says pass off the commit status. Well, it doesn't quite work because that would then not commit it in real time if it was not committed in day ahead. So we end up using the day ahead generating units generating property. And so what's interesting is that this is a modification of the right-hand side of a constraint, so you kind of have to play around with it a little. And so the solution here was that the day ahead run can create sort of like a synthetic data file, which can be passed to the interleaved model. And so when the second pass, the real-time pass, is using this pass commit data file, if the constraint name is the same as the generator, then it can actually use that data file property value. And so then that passed the commitment 0 or 1 into the real-time model, and it just said that if the day-ahead commitment was 1, then the real-time commitment has to be greater than or equal to 1, so it runs the unit. Otherwise, it looks at the economics in real time to commit. So I figured that was worth sharing. So what did we do with all this? So the forward methodology was used in delivery year 2022, 2023. Unfortunately, then there was some additional changes, regulatory changes. We went back to a pseudo-historical model using historical prices, but within the PLEXOS tool. And then we used this in the MOPR exception process, looking at if we had any requests. We did some unit-specific analysis with this kind of revenue generating. Then PJM switched it again. We're now doing MSOC, the minimum seller offer costs, and which is now a function of, instead of net cone, now we're net ACR. So you put the net energy revenue into the gross ACR. And then, we've been going back and forth on a whole bunch of issues at PJM with the capacity market. And these little issues have been bubbling up over the last couple of years. That the resources are, saying that they have different accreditation issues, like looking at ELCC. Are we procuring the right amount of capacity in our markets? Are the resources that are bidding into the capacity markets adequately covering their capacity performance risk? And then lo and behold, in winter of last year, we had a performance assessment. So essentially, we called the resources to perform as they were cleared in our capacity market over Winter Storm Elliott, December 23rd and 24th. About $2 billion is now changing hands because of that performance, and it kind of shocked a lot of people that what's the value of the capacity performance. This led us to we had been working on our 4R paper, the resource retirements, replacements, and risk throughout last summer, doing an economic analysis, and we refer to this model within that paper. That was a paper that was looking at policy risks out to the year 2030, and then doing some economic modeling as well, to say if we have a small amount of economic risk, revenue adequacy risks. And so there's just generally a lot of questions. And so that led to am I clicking the right button? Oops. Need to go back one, I'm sorry. Okay. So the So we've started this new resource adequacy critical issue fast path process. Those who are paying attention to PJM, it's a kind of a big deal. And so while that was going on, we approved this projected net EAS process as part of our quadrennial review. And so this methodology will be productionized and in use by our capacity group. I would say it's the first real use of PLEXOS in a non-research and development role at PJM, and we'll be using this to solve the combined cycle resources going forward. As of last Friday, FERC has approved our delay of those auctions. So at this point, the 2025 auction, I believe, will be delayed to at least next year, possibly June of 2024. The 2026 auction that would have used this code should be coming soon. But we don't have a firm date there. But yeah, so this is our use of PLEXOS in an operational role to help feed information to our capacity market.